Welcome to the Munro Live podcast. I'm Tom Perche, Director of Electrification for Munro, and we're here today to talk to some folks from TE Connectivity. We have Kelly York, who is Director of Customer Engineering, and Aaron, I won't try to pronounce your last name, Chazal?
Chazal, yes. There's a bit of a
Okay.
French element there.
Very good. Okay, great. And Aaron is Senior Manager, R&D and Engineering at TE Connectivity. To start this out, most people know my background on this channel as Director of Electrification. My focus has been automotive electrification for the last 17 years. I bought your products when you were Tyco. So, okay, there's that. That was 2011 when the name changed, if I remember correctly, to TE Connectivity. So, please, Kelly, tell us a little bit about your background, give us an introduction, and we'll go with Aaron next, if you will.
Sure, no problem. No quizzes on naming because you've known us longer than I've been here. So, but thank you, Tom, for having us here today. Appreciate it. So, as you said, my name is Kelly York. I'm Director of Customer Engineering. Customer engineering is kind of a unique term in the automotive industry. So I'll touch on a little bit on what my responsibilities are at the organization.
I really want to know about customer engineering because I'd like to engineer some new customers for us.
Yeah, that's not it.
Oh, darn.
So we are focused on our customers, first and foremost, in supporting them. I have two managers on my team that are responsible for a group of resident engineers that work closely alongside our OEM customers. So they spend as much time with them as possible on a day-to-day basis, solution solving. So in addition to that, I have responsibility for our field application engineering team. And unlike residents who are assigned to a specific OEM customer, field application engineers are assigned to system-focused areas. So for example, EV powertrain or safety. And they work across our customer base and then bring insights from cross-customer back to the organization.
Great. Aaron, tell us about yourself.
Yeah, sure thing. So I report to Kelly here in the customer front-end team. And I've been in the automotive industry in the connector supply for 28 years. I started as an engineer in stamping and molding back in the late 90s, working on vision inspection systems. And then the last 17 years of my career has been spent here at TE in the high voltage connections group, including 10 years as a development engineer and handling harnessing and high voltage connectors. The last 6 years of my time here has been spent managing charging inlets and that development engineering team. And just about 6 months ago, I joined the front end engineering organization under Kelly, managing our resident engineering team here for North America.
Very nice. So I should probably let the subscribership know that we did do an interview with another TE person, VP of Engineering and CTO, Jeremy Patterson, back in January. So there'll be additional information people can find out about TE from that interview. And what we have to talk about here looks to be a pretty good extension from that interview. And we're going to get into some more detailed discussion than we did then. So with that, I do have a nice list of questions to go over here that I think will get us deep into the root of what you do and what's happening in the automotive community at large. So, start with, all these market trends are happening. Which ones are affecting you? Which ones are you up to your neck in and trying to help out with? Everything from autonomous driving to software-defined vehicles. High voltage, ever increasing higher and higher voltage. Battery life, meaning, more calendar life, more, miles, if you will, that people want. How much range you can get is another big thing. That's a huge increasing trend, lagging EV adoption in North America. Why are we so far behind? So, I don't know who's best to take the lead on that question, but I'll leave it between the two of you to take on that challenge. Tell us about market trends and automotive advancements.
I can start, Tom. So you named so many, it's feeling very overwhelming now. But,
Well, pick your favorite.
I'll pick a few. So I failed to mention that prior to TE, I've been in the automotive industry for 20 years in various roles, and most of my experience prior to joining the organization comes from power signal and distribution systems. So working on wire harnesses. So when we look at market trends, and I realize the most common, most exciting response would be to say the trend towards autonomous driving, is one of the biggest influences and biggest challenges in vehicle architecture. But I feel the most relevant trend that we're seeing today is really the consumer's expectations for an increase in vehicle features and functions, and not just the increase in the features and functions today, but the ability to add functionality in the future and update in the future over time. And I think that really this push from consumers and the industry, where we're no longer looking at the vehicle as a transportation mechanism, but really a customized driving experience, this is where we're seeing the most pressure and seeing the most changes in the vehicle architecture. And really, in order to meet these consumer demands in functionality, the industry has had to shift to this software-defined architecture. So I would say that is where we're seeing the biggest challenge and the biggest shift in the industry.
Very nice. So, it's a confusing thing for the user community because they see electric vehicles, for example, as having this extraordinarily high price. Yet, as an evaluator of that technology, I can't help but notice that it isn't the electrification of the propulsion system that causes that. It's all this other stuff, the big gigantic displays, the ADAS, as you said, being able to provide this ever-changing future through over-the-air updates and software definition of features, that, adds a lot of cost. And if you add that to a regular combustion engine vehicle, it kind of does the same thing to that. So, how much of that is, inevitable and here for keeps? As we move towards an ever lower cost car, we're going to have to forego some of that feature set, or are we? Tell me.
Tom, I'd like to jump in a little bit on that one. The question of scaling the costs, right? That's something that we're dealing with. We see now in the electrification of the automobile, in effect. If I could sort of transition in there, because we see so many costs associated with these new vehicles, their capabilities, but we also have to acknowledge that we're not necessarily there in terms of the scale, in terms of making our manufacturing processes as efficient as they could be in making, rather than 10,000 or 20,000 vehicles, when we're looking at making 600,000 or 700,000, now we can take advantage of those and bring some of the costs down. I think we've seen that historically as we looked over where technology advancements have come through the automotive industry. I'm of the age where I remember when my parents would say, "I'm not buying a car with automatic windows. They just break down and they're expensive." And now that's a standard thing, right? It's something we unless you're an enthusiast of off-road jeeping or something, you would say, "Yeah, I need power windows in my car nowadays." And we see that transitioning. Kelly and I were talking this morning about things like heated seats and things like that we're getting used to this new technology, 14-inch screens and things, where the costs will come down over time. I'm a proponent of saying we should very much expect to continue to see these kinds of improvements over time as we get better at making them.
Yeah, well, that's a good point. And with scale and the economy of scale, yes, maybe we get to keep these features and have a reasonably affordable car too. So I'm looking forward to seeing that happen. Right now, today, not so much. It's it, to the consumer, it doesn't look like there's much end in sight. But the one thing we do know is that the electric vehicle has a reduced bill of material And a good part of the reduction in the bill of material is the moving parts that disappear. So, logic would dictate that eventually it'll get more reliable and likely less expensive as well. And yeah, we just have to cope with what is the evolution of the automobile in general and the feature set that we've grown accustomed to. So good stuff. So, what about higher voltages? What's that doing to your life? We spoke a little bit with Jeremy about that, but where's it going after 800 volts? Are we going to see 1200 anytime soon?
That's a really good question. We are seeing 1,000 volts, right? That's where we're sort of rating things at this point, sort of the high end. We're looking at that level. Um, Again, I like to look at the history of, well, what was the value proposition? What is the value proposition of going to higher voltages, right? Not so long ago, electric vehicles were running, typically 400 volts. And I think it was maybe it was like the 2019, the Porsche Taycan came out and they said, you know what, we're doing 800-volt architecture here. And it was a game changer in terms of what they could do. Um, I don't know that we're going to go into the details of, power is voltage times current, things like that here, but we all know, right, if we've spent any time in the electrification of, well, pretty much anything, as we get the voltage up, we can drop the current, we can reduce, cable sizes and things of that sort, we can reduce heat. And the benefits become I guess I'll just say very tangible of what we can do, the power that we can bring to the system when we do that sort of thing. So your first question to us was market trends, automotive advancements, what's coming. And Kelly mentioned autonomous driving, software defined vehicles. And the high power, high voltage, that's another huge category for us. I don't want to confuse that too much with electrification, right? Because we all naturally go there that, oh, he must be talking about electrification. And that is true to a large extent. However, we are seeing higher and higher power demands even in standard automobiles and hybrid technology, right? Transition to 48 volts is the same thing. We did try it a long time ago. It didn't take off back then for various reasons, but things have changed in the last 10, 15 years, making this much more of a reality today for us to jump to higher voltages, even in what we would traditionally consider our low voltage systems.
Yeah, I find it fascinating that the increase in voltage, as you mentioned, also gives you an increase in power, and that can translate into more mechanical power for better acceleration. And in the case of Porsche, they probably took a little bit of an advantage of that. But at the same time, it's also about improving efficiency, lightweighting, less copper. So it's a burgeoning question for me. So far, with few exceptions, it seems like most of the 800-volt passenger car architectures were all about higher levels of acceleration performance. Hyundai has an 800-volt architecture that seems to, also improve that acceleration, but it's also now taking advantage of that reduction in conductor size and all of that. What do you see going forward? Is it going to be a mixed bag of trying to improve efficiency, lower cost, lower mass with higher levels of performance, or will it trend one way or the other? We have this expectation of ever faster 0 to 60 times, and as a performance enthusiast, it's kind of mind-boggling that people still want to go quicker yet. And it's amazing to me. So go ahead and tell me what you think. Are we going to see, that 1 second 0 to 60 that everybody's expecting as a result of this? Or is it going to be really more about getting them the low cost economical car that they've been waiting for?
Well, Tom, here I guess I would say this audience are probably largely enthusiasts of, let's just say, the automobile itself, right? And we've seen over time, depending on the car company and the car they are making, that's how they're going to decide what they're going to do with that additional power, right? Toyota Prius, they're probably going to find ways to make it more fuel efficient, right? Do everything it can do more efficiently. Porsche, Lamborghini, Ferrari, they're going to take all that and put it right to the road. And they're going to push the limits of the tire contact patch in terms of, can I get to 0 to 60 in 1 second or less? And that's one of the fun things about the industry that we're in today, is that there's not just a directive to go one way. If one person likes to, carve the streets up, we're going to give them that option with their power. If one person prefers super efficiency, we're going to give them that option.
Great. And of course, there will always be the blend, and that's kind of what's in it for everybody. So, we kind of touched on most of these market trends, unless we want to touch a little bit on that lagging adoption here in North America. Why are we so behind the eight ball here? And are we going to catch up?
I feel that we're going to catch up. We might have been a little bit seeing our customers a little bit aggressive with the commitments originally, but I think we're going to get there. But it just might be a little bit slower. The lag, I think, as efficiency improves, as you mentioned, that there will be more adoption. And I think as the infrastructure changes to support the electric vehicles, there will be a faster adoption as well. And, Aaron can probably, touch on this a little bit more, but as we look at the charging standard changing in the US to the North America charging standard, and having that standardization across the charging units and across the vehicle lines, I think will increase consumer adoption. Because, we're still seeing that, that fear of not being able to find somewhere to charge in time. And, if you live outside in the city in rural areas, you're driving a lot farther. So I do think that we will catch up.
The United States brings somewhat of a unique space to this, right? Just because we do have these very long distances to travel. So that's one way of sort of excusing where we are perhaps with the electrification and, as you mentioned, the lagging adoption of EVs. But, one of the things I want to do is I want to give the OEMs huge props for what they've done in this space, even here, our local OEMs, because think about it, they're actually providing the leading charge here with this technology that they're putting out. The number of vehicles that they are launching that are electrified is outstripping the ability of the infrastructure to keep up. I would rather have it that way than the other way around, where somebody's building a ton of charging stations, but there's no vehicles to fill them. Because this is putting the product in the hands of the consumers and allowing the consumers to decide, do we care about electric vehicles or not? Now, it's perhaps gets a little contentious because we read in the news, well, electrified vehicles right now they're really struggling. They're not. It's not growing at the pace that was anticipated. But we don't have to look very far to realize, yes, maybe they're not growing at the same growth rate that we've seen in years past, but they are still definitely growing. Now, I have to admit, I don't own an electric vehicle yet. I am not an early adopter, but I'm still a proponent of the technology because of what it means for us in the future. All of that technology that we're putting into the electrification of vehicles, into the advanced driver assisted systems, ADAS and whatnot, that carries down and flows down into the vehicles that everybody is buying today and makes them better in so many different ways, whether it's hybrid technology or electrification. So, yes, I suspect we're lagging where we would wish we were in the electrification of the automobile, but I still see it as just a tremendously bright future, even here in the US, where people are saying, well, we don't have the population density to really justify it. But wow, the technology that's coming out of it is tremendous.
So we've got another area to talk about here. Vehicles evolving to meet the consumer's demands. So what are they demanding, and how are we trying to achieve, the realization of their demands? So we have the new zonal architectures, different architectures for powertrain. What's back suddenly? Hybridization. Plug-in hybrids are suddenly popular. Who would have guessed? That and, modular connectivity solutions, trying to use things in a more kind of a reusable way across platforms. You got, standardization. NACS was mentioned. I've got some strong opinions about that. But are we meeting these demands satisfactorily and on the time frame that the industry wants? Are we lagging in providing that? Or maybe we're ahead of the game. There's a fair argument against being too soon is almost worse than being too late, right? So are we creating an architecture that's scalable at the right pace, or what do you think? Is it lagging or leading what's needed?
Yeah, I can touch on this. So, Tom, you mentioned our vehicle prices. Are the features driving the increase in prices, and do we see some of those features eventually backing away? And I think that the answer there is no. I think that consumers are going to continue to demand more and more from their vehicles, and that customized driving experience. And I think that we're doing a good job of keeping up with consumers today, but that is going to continue. I was thinking about, as Aaron mentioned, the progression in the technology, just from, power windows. It's many of the luxuries of the past have really become necessities nowadays. We've come to expect that our vehicles have safety features, such as blind spot notification, adaptive cruise control, lane departure warnings. And then when we look at infotainment, we now have apps to monitor our vehicle's health, start our vehicle, and connect our phones to our radios. And I think we're going to continue to see this evolution of functionality and features in vehicles. And the transition to the software-defined architecture is allowing for that growth in the features and functionality. I think that, to your point, it's driving a higher amount of content, a higher use of coax and Ethernet and data connectivity connections in the vehicles. And we just need to work together with our customers to figure out how to best optimize that architecture in order to bring the cost down.
Very good. It's kind of a lifelong pet peeve of mine when you see new automotive technology being developed and the existing car that has the old technology still seems to sell just fine. So somebody makes the decision, maybe we'll introduce that next year or the year after. And it extends out this process of, advancing the state of the art and makes us lag as a society because the old stuff still sells fine. So that's kind of the sweet spot. I'm wondering, are they spending the right amount of money to bring this forward in the way that can keep this juggernaut going? Or is it just going to be, all right, let's make the bucks we can for now, as it's been for 100 years of car sales? So, I don't know if that adds another reason to comment, but if it does.
It does.
All
It
right.
does, absolutely. And I have to jump in here. You know, without naming any specific companies, maybe we'll just call them prominent West Coast electrification companies, right, who are making automobiles. I think you're on point, Tom, about the fact that technology has not moved as fast as it could, right? Because perhaps, as you said, consumers are just okay with what they currently have, and it makes money for the auto industry, so they don't bring anything new. But again, the value that some of these newer companies who are not saddled with 150 years of the way we've always done things, bringing new things to market, and I'm not just talking about an electric vehicle necessarily. I'm talking about a new way of processing a vehicle, of looking at how a vehicle gets made. How technology in solving problems, new technology in solving problems. That's where this huge value that they bring comes from, in my view, because they're willing to say, we're going to do it a different way. We don't, a perfect case in point, 12 to 48 volts, right? How many times guys like us, we've seen it a million times. It's never going to work. And then now one of these new companies comes in and says, well, we're pushing to 48 volts. Most of us tend to say, and you'll probably be successful at that. This could be the change that we need. Why? Because we look at the things that hold us back, the things that keep technology from changing, as you mentioned. all of our systems are designed, for instance, around 12 volts, right? If I'm building a car and I want to go buy a wiper motor, I want to go blow a blower motor or a headlight system, it's all around 12 volts. Now we've got companies who are legitimately making vehicles who can say, you know what, we're developing systems that can handle 48 volts, 36 volts, whatever it might be. Now we're starting to change the narrative because the components that are available can handle it. And we can get out of this sort of old school way that we've always done things and say, oh, there's another way to do this. So yes, back to your question, we are not moving as quickly as we should. And that's why it's so much fun to watch the teardowns of some of the vehicles that you all have, is because these are companies that are looking at new ways of solving some very old problems.
It's interesting. We're in the process of the teardown of the Tesla Cybertruck as we speak, and we're keenly interested in the 48-volt architecture that vehicle brings to the table. My curiosity is focused on whether or not that's sort of a superficial investment where, okay, great, yeah, it's 48 volts, and then there's all these 12-volt down converters everywhere, hoping they spent the money on the 48-volt motor that runs continuously for various functions that would have a meaningful effect on range and performance. So, yeah, I'm one of the few vehicle owners that actually has a 42-volt architecture from the last time we tried this. And yeah, it kind of fell on its face because we didn't do that, right? And okay, are we going to do it this time? Tesla seems to have their heart in the right place by trying to initiate the second round of this. And to me, it's all going to be about whether or not underneath it all, the investment's been made in a way that's meaningful and whether it'll inspire all the other bits to go away. Can we truly get to a fully 48-volt architecture, but will legacy, continue to hold us back?
Right. Now, Tom, you mentioned a little bit ago, it was very quick in passing. We were talking about NACS just briefly, and you said something to the effect of, and I have opinions on that, something like that. And I'm very keen on hearing those opinions because that NACS, and I'll go first just so that we know I'm not biased by what you say, but in the electrification space, we see NACS as absolutely the right direction to go, as a perfect example of, hey, we should have done this a long time ago. When we look at the CCS, the combined charging system standards, and what that results in, I mean, I could put up on the screen right now, an overlay that shows the NACS charging gun overlaid over a CCS charging gun, and you see the size difference. And then, to the untrained eye, they would say, yeah, but the CCS system has both AC and DC. And it's like, no, it really doesn't. That huge charging gun is only good for DC charging. It's a waste of materials. It's a waste of weight. It's a waste of so many things. And yet, without some of these, shall we say, pioneering companies who are willing to come and say, we're going to make a new mousetrap, how long would we be saddled with the CCS charging system? Now, I'm curious to see what your thoughts are on that, because you had mentioned that you have an opinion on it.
So, and I'm a storyteller, so unfortunately, you just triggered another one. So we tore down a Hyundai Ioniq 5, and we had this mysterious discovery of a 3-phase drive motor for the rear propulsion system that had 4 leads going to it. And what the heck is that all about? And we chased our tails for a few days until we figured out that Hyundai had a patent on taking 400-volt DC fast charge and boosting it to 800 volts by using the electric motor and its inverter to do a boost converter function. So really innovative, because Porsche does the same thing, but there's a box that'll do 50 kilowatts that is dedicated to that purpose. And Lucid does a similar thing. Porsche even has an optional 150 kilowatt box you can buy if you really want even more DC fast charging. So, the point of being able to reduce the cost to deal with the 400 volt infrastructure is my key into the NACS thing, because we have a 480 volt 3-phase infrastructure here in the United States, and we're trying to go to 800 volts in cars. And you can't get to 800 volts from 480. So what do? You have to boost. And if it's not in the infrastructure, it's in the car. So, Tesla built quite an empire around the 480 volt three phase sort of infrastructure that we're all living with. But they too, and we see it first here on the Cybertruck as their first 800 volt version. They too recognize that their entire supercharger network has to be upgraded to 800 volts. And to me, what better way to do that than on the backs of a bunch of other competitors that are going to pay you to do that? So I find that to be kind of unique to Tesla, in that they've offered this up as a world standard altruistically, while simultaneously providing a funding path to create their own 800 volt version of their system. So, and last part of the story, it's kind of akin to, altruistically, let's let them use all of our patents. What better way to keep your competitors 10 years behind than to give them all your old stuff? So, that's kind of my thought about it, is that, it's an evolutionary step. And once we get to 800 volts and it stabilizes for a while, it'll probably be pretty good until we go to some higher voltage yet. So I don't know what your thoughts are on that, but probably wasn't the answer you were expecting.
No, but it was a good story to hear. I mean, I think you're on point with a lot of those comments there. And my take on it, we talk a lot about the altruistic aspect of this, and is it real? Is it altruistic, or are there, is there things going on in the background? But we try to look beyond that and say, ultimately, what's for how we got there is important, of course, or how we'll say they got there. But where have we gotten to, right? Have we gotten to a better place as a result? And it was messy getting there. But as you said, once we get to 800 volts, will we be in a better place? That's, from an engineering standpoint, the question that we really need to ask. And do we need to go beyond 800 volts? Who knows? At this point, it's difficult to see, why would I need more than 800 volts in a passenger vehicle? Sure, farming equipment, heavy trucks, things like that, I get it. But I'm pretty sure that 20 years from now, we will be pushing beyond that, beyond 1,000 volts even, for some reason that I can't define today.
I have the same vision with a similar lack of explanation for why. So,
Yep.
Very good stuff. All right. Guess enough about charging. You have challenges as an organization, things that are inspiring you to innovate further. Can you give us some clues? What sort of connectivity challenges are ahead? What are you working on that might be more difficult to solve, or something that causes you undue pain at this moment? I don't, kind of a leading question, but, just wondering if you can come up with some sort of thing you're facing that's daunting in its challenge. And if not, that's great. That's wonderful news. So no answer is best answer.
Nope. If we had no challenges, as you said, undue pain, right? Without undue pain, we're just not going to make progress, right? And as you've probably surmised from the comments that I've had so far, high voltage and charging is kind of my space. So I'll just jump in briefly with that. And the challenge, one of the biggest challenges, is just how to get more power, right? How can we get more power? And from our standpoint, how can we transfer more power? Our TE connectivity we're not responsible for generating the power. We're responsible for getting it from one place to another. That's our thing. And so we have to make connection systems that, for instance, in the high power space, high voltage, we need to reduce the resistance, right? Oh, it's pretty easy. You just make sure that you clamp these two wires together, or clamp these two bus bars together, and you're transferring power. The trouble is, yes, but we have to be able to manufacture these vehicles, assemble them, at a specific rate. And so we have to have these, what we call a high normal force connection, or very low resistance connection, that can actually be assembled by human hands relatively easily and relatively quickly. So, bolted interfaces, very robust, right? But they take time and tools. And high normal force connectors can be very difficult. If you got a big connector system you're trying to jam together, it can be very difficult to actually put that together. So how do we transfer high power with low resistance, right? So we can eliminate heat, right? Because heat is the devil in everything we do in high power. That's one of our big challenges. The other key challenge I would say in this space that goes along with that in high voltage related are things like safety and arcing, right? Those are huge challenges for us. In the automotive space, you think about your electric vehicle, we're handing a 200 plus amp charging gun at 600 plus volts to a consumer on a rainy day and saying, hey, let's charge our vehicle here. Now, never mind that it's carrying more power than your local subdivision is, but we're going to give this to you and let you plug this in. So how to make that safe and how to make it reliable and robust, those are some of the key challenges in the high power space. Kelly, I'll let you get into some of the other areas.
Sure. So challenge is not a bad word, right? Because challenge means opportunity. So an opportunity to provide a solution. So I'll touch on some of so like Aaron said, he focused on the driving power or bringing power in the vehicle. So one of the things we're seeing is an increase in data as well, an increase in data connectivity. So as we have the central computes or the computer systems that are added to vehicles, we need to move the data from the sensors, radars, cameras into the central compute fast. So we're seeing a larger need for data connectivity, Ethernet, as well as I would say an increase then, since you have more data cables along with your signal and power, we're seeing a unique need for data signal hybrid connection systems on inlines. So that's driving a new type of product, as well as a need for miniaturization. So actually looking at the connectivity inside these devices. We've had computers, but they're not inside vehicles until today. So, what requirements do they need? So board-to-board connectors and smaller connection systems for modules is what we're seeing. And then, like anything, we're seeing an increase in customization of connectors. So each of our customers has a unique way of implementing their software-defined vehicles. And so we're seeing an increase in the customization of the headers that go on those modules and higher pin counts because more content driven by the features. And with higher pin count comes, its own unique challenges, where, as Aaron has touched on, manufacturing a vehicle brings its own set of problems. You have a higher mate force. You can combat mate force with lever assist connections, which we're seeing an increase in, or we're looking at new plating technologies to actually help with the ergo force when mating the connection systems. But again, there's challenges out there, and we're here to help work alongside our customers to provide solutions to those problems.
Very nice. I think about the subject of heat. It's an artifact of putting current through a conductor. There's IR losses. It has to get warm. You either have to lower the resistance or somehow cool it, right? So I have a lifelong fascination with superconductors, and now we have reasonable high temperature superconductors. Yeah, it might require liquid nitrogen, and we are already seeing the need to cool cables at charging stations as we approach 250 plus kilowatts. So this was a more conventional type of cooling. What's the ramification of that? Are we going to see the same sort of need for cooled conductors in the car as we go up, or are we going to just use more copper? And will we ever get to a point where there's some justification of some sort of active cooling medium like a cryogenic fluid? That's a really visionary statement, and I know I caught you off guard with it. So feel free to say, well, future will tell. But if you have an insight, I'd love to hear it.
Well, I'll jump in on this because that future's not far off. It's actually here today. Um, we spend in our engineering groups a significant amount of time trying to figure out how we can limit heat. Mostly where do we see that? We're going to see it in the DC fast charging systems, right? Again, we keep coming back to charging, and I want to get away from charging if we can because there's other things to talk about. But since you brought it up, Tom, um, extracting heat, we've got systems in the vehicle where we have, integrated liquid cooled systems for the charging to try to cool things down. But in that innovation, we've also realized how expensive it can be and the technical challenges associated with doing that. And where we would like to get to is more passive cooling, right? You mentioned more copper, that obviously works well, but more aluminum also works well, right? Any way that we can shed heat or move it to another place, heat pipes, things of that sort. There's several patents out there that you can find in the charging system for ways of extracting heat. Now, I know nothing about the semiconductor world that you mentioned there, and you could teach us something about that. Um, but that is indeed a topic where I would say, there are certain charging systems out there that you could pull out of a vehicle, and what you're asking about, we would say, here you go, Tom. We've got one that you could look at today,
Nice.
and it's in production.
Yeah, my elusive reference is, for years we had an AC power system that sent power across the country. And now with the advent of high temperature superconductors, we are able to send power in a DC form for long distances. So it seems to be paying dividends in the infrastructure now for long distance power lines. But my hope is that we find some of that technology become cost effective and find its way into cars. And why? I'm a lifelong gearhead. I like the acceleration performance. I do want the 1 second 0 to 60, and I know it's a challenge, and we need some monumental advancements in technology to make that practical. And I just kind of hope it happens soon. And it's very encouraging to hear that, the idea of a cooled major conductor in a car, or one simply passively cooled, as you said, without any extra system to do the job. That's wonderful news. So yeah, moving away from charging systems, hopefully, but you never know what triggers that subject back again. Connectivity, it's such a wide ranging terminology. It means different things to different people. There's these, the connectivity part of it. I want my, phone connected to all sorts of different things. But it's more than that. Tell me what connectivity means to you, and how does that apply to like architectures of vehicles today, or will connectivity change beyond what we're already envisioning right now with regard to the software definition and over-the-air updates? Broad ranging question. You named your company TE Connectivity, or it's about connectivity, right? But tell me your version of it. What does all that mean? What does connectivity mean to TE?
Well, I mean, it really means what the word is, right? We're connected in everything in the vehicle. Now, TE Connectivity is a large company that makes connections for all kinds of industries. But if we focus on the automotive space here, think of connectivity for a moment in the space of like safety, right? How are we connected in the vehicle for safety? Now, there's a zillion different reasons to be connected, but safety is one that most people can identify with. And for instance, I was telling Kelly, we were chatting about this ahead of time, and I said, my daughter sent me a text, a few months ago. She was headed back to college, and the text said, "Hi, Dad. Evidently, I can't crash this car." It was a car that we had gotten her to take her across the country to get to college. And as a parent, you say, okay, I'm going to need more information, and I'm going to need it quickly. Okay. And very briefly, she was driving on a rainy road, and it was foggy and whatnot, and the car in front of her had stepped on the brakes very quickly, faster than she could react. And she said, well, the car in front of me slammed on their brakes, and before I knew what was happening, my nav screen strobed orange, and I got an audio alert, and the car slammed on the brakes. And she said, I never would have stopped in time. I would have plowed into the back of them, and I'm shaken up, but I'm safe. And I said, that's it. This is why I became an engineer, for the connectedness, right? That said, okay, in this vehicle, there's a radar system looking forward. That's connected to a wire harness. That wire harness is connected to the vehicle's central computer unit. Central computer unit's making decisions about the object coming up in front of my daughter who's driving her car at 55 or 60 miles an hour on the highway. That system is constantly making thousands of connections every second, sending that through another connection that's going to pulse the brakes or put on the brakes in an emergency fashion, send out the strobe to the nav screen so everything flashes orange in the car to wake somebody up, and then give them an audio, a warning about what's going on as well. All of those things how many connections were there? I don't know, 10, 20, 30 connections that only had to work or only have to work a few times, but every time they have to work 100%, right? And so that is a good example in my world of the role that connectivity plays, where we are no longer simply for safety reasons putting a padded dashboard in and a passive safety restraint. We've got vehicle systems that are communicating with the driver, but as well as with other vehicle systems to make this steel box that's moving down the road at 70 miles an hour a safer place to be.
So much more than the old Tyco electrical connector as connectivity. For a definition, it certainly has come a long ways. So, with TE being involved with the design process, I know it was one of the things we touched on with Jeremy, and something that I took away as something I didn't realize is the partnership that TE can be with regard to an OEM or tier one that's trying to evolve their product. So, how involved is TE in that design process with the OEM or the tier one? Are you sitting there in the seat with them effectively, co-developing, or are you more pioneering your own, versions that you try to convince them to buy next? Or is it both? So, how entrenched are you into that OEM or tier one view of the evolution? Or are you just simply playing that tier one, tier two role of, here's my product, buy it? So, I don't know.
I
Interested
can
in your
start with
response.
this one.
All right, good.
Yeah, no. So yeah, this is customer engineering. This is working with our customers. And as you mentioned, we have a large amount of customers across the industry. And it's one of the reasons I love my job personally so much, is interaction, because just like no two individuals are alike, no two customers are alike. So to answer your question, how involved are we? There's varying degrees of involvement, and that really depends on the needs of the customer, because they all like to take different approaches to problem solving. We are looking to partner with our customers as much as they'll let us, to sit alongside with them to come up with design solutions. But there still is the traditional approach to keep it in house, come up with the design and send it out, as an RFQ after they've fully baked the idea. And we're open to supporting those opportunities as well. So it really depends on what our customers are looking for. Obviously, working with a variety of customers, we feel that it brings diversity of thought and innovation to our engineering teams. And so the sooner someone is willing to work with us on a design, we're able to bring new insights and provide guidance. But again, it's that, customer's personal perspective on the approach that they want to take.
All right, good. But I can't say enough how valuable that is to me, because, the automotive engineers that I've known through my life, and I've known a lot of them, they can oftentimes find themselves tunnel visioned in their own little world, and, fraught with legacy and, preconceived notions about how the things need to work, and without a fresh viewpoint from outside coming in to give them some new ways of thinking, then they're kind of doomed to keep repeating the same mistakes. So it's really nice to see that you step up in that way and provide them, some grounding and some vision to go beyond the box. So good work. All right, architecture shifts, technology advancements. How is that going to impact your connectivity innovations the most? What's going to be the advancements that will change your, approach to the market? Manufacturing shifts, how our connections need to be made. You mentioned ergonomic forces and things of that nature that can hold us back, and lever mechanisms that might make that okay. Labor rates, need for automation. Everyone's worried about their job being displaced by the ever intelligent increase in manufacturing capabilities. Modules combining, pin counts. You mentioned signal and power with now high speed data. What are these things that are going to be taking up your time in the future the most? You've got a pretty good legacy behind you with a huge library of fundamental components for people to work from, but you're working on the next thing, right? And I'm just wondering, what are these shifts that are happening that are going to consume the most effort on your part? I don't know if that's a good way to word it, but I think it's as good as I can get right now. So,
No, that's a good one. Let me jump in there and see what I can throw out there for you, Tom. The key thing that you've mentioned there is, I guess I'll paraphrase, progress, right? What's the next thing that we're headed towards, and what impacts us? So, for instance, just one example, say automation, right? You touched on automation, and what is automation going to mean? Automated assembly is huge for us. We're rolling through, I don't know, 70, 100 years of connectivity in the automobile that's designed. If you look at a connector, right, put an alien on Earth and have him look at a connector, he's going to say, this looks like it's designed to be manipulated with human hands. Now, why is that? Because you put it together once, and then ideally you never touch it again. So why are there levers and bolts and things like that? Why is that necessary? And that's where this whole business of automation starts to come in. When we start to see robotic systems putting wire harnesses in the vehicle, putting instrument panels in the vehicle, things that have traditionally been managed or handled by human hands, that's where some key things are going to start changing. We already know, for instance, that robots are welding frames and things like that together in the assembly plants. Why are they doing that? Well, A, it's safer, it's faster, it's more precise, right? I don't want to get into the question of labor rates and things like that. Frankly, I think labor is always going to be safe in the plants because we're always going to think of the next thing that we can do. And that's by and large going to need to be put together by hand at first for some period of time. But these large structures, I think we've heard of the giga castings, and right, you guys are seeing that in the vehicles that you guys tear down. These massive things that we say, what this vehicle could not be put together if we don't in the traditional way. And so we get into the robots, the automated assembly methods, and in our world, those connections that we make now by hand are going to be switching over to methods that can be handled by automated systems. As I indicated, sometimes it's due to cost, but also that element of precision and repeatability that's necessary. The other big one, I guess I'm kind of reiterating, though I want to throw it out there because it's so important, is safety. Safety is a huge driver. It's technology advancements in safety. That's where we love to play. What can we bring and make more robust in this automotive space? Kelly, anything you could add?
I think I'll just, when we look at the changes to connectivity in the industry that are driven by the architecture changes, we've talked to those, and Tom, you mentioned them and reiterated them again, the data signal hybrid miniaturization. I agree with you, Aaron. I think the next biggest challenge for us will be the change in the manufacturing process of the vehicles. And so not just how the components like the wire harnesses are laid into the vehicle, but how the actual vehicle is put together and assembled. We're seeing where a battery used to go into a vehicle for an electric vehicle, but now the battery is actually becoming the floorboard of the vehicle. And as our customers start to assemble their vehicles differently, it's going to drive a new need for a different type of connectivity. And I think we don't know what that is right now. And that's where we're really focused on trying to understand what problems are going to come from this new approach and how we can bring solutions in time to be there and ready for them.
All right, good stuff. So now I have one that I may also catch you a little bit off guard, but I have a good feeling that it'll give me a response nonetheless. So 3D printing, it used to be kind of a novelty. It wasn't very practical. When I got in the business, we had these SLA parts that were just terrible. You could use them to maybe sort of visualize what it might be, but don't try to make it useful. So now we've evolved that, right? And now we're 3D printing parts in production. I'm pretty sure that runs into your realm a lot. You're not going to tool up some high volume connector unless there's volume potential for that connector. And in the meantime, can you 3D print a prototype? And at what point does that prototype become a production part remaining in a 3D printed format? In other words, there's always this level beyond which you make the investment in the tooling and do it with injection molding until what you have to make can't be injection molded. And so it may not matter what that crossover point is if you can't make it with the old school methodology. So I'd love to hear your response on where that's going. Are we going to see that in a wider sort of implementation than simply, I'm only making 200 cars, so I'm not going to invest in tooling for the embles, the monitor. What's the word I want? Small parts that would normally be molded that you can just print it out and nobody knows the difference, but I didn't have to spend all the money on the tooling. So tell me about how that fits in your world. I got a feeling it's a big part of it.
I have things to say, but I want to give Kelly an opportunity if there's anything she wants to put in there too. I've always got things to say. So
it's out of my element, so I'm going to let you, Aaron, but I am stuck on just Tom's comment of the old SLAs because I still remember those early too. The white material, it was always white, couldn't be any other color. And
until later, it was kind of amber and ugly looking.
They took forever to make. I mean, it was like this slow process to even produce them. So I know the technology has come a long way. And Aaron, I know we have utilized it in amongst our teams on prototypes, but why don't you go ahead and touch further on what you know?
Yes, the old SLAs. It was the one reliable way to give your customer a bunch of broken little pieces when you wanted to show them something.
And to turn them off forever.
Right. It reminded me a little bit of, you're probably all familiar with that video game all the young kids seem to like to play recently where you're building these little blocks, right, and putting things together.
Minecraft.
Yes, Minecraft. But so the question really was, where do we think 3D printing technology is going to go, and do we think it's going to maybe supplant, production methods that we see today? I see the answer as a possible yes, right? There's no doubt we can make things with 3D printing technology that we can't make in a traditional mold. The most impressive of that sort of thing that I had seen over the years was where they're actually making like sintered metal parts, right? Where, I mean, plastic's one thing, right? But now all of a sudden, can I make a I was going to use the example of a carburetor, but hopefully we don't need to make carburetors anymore, right? But something equally complex, right? It's a block of metal with a ton of passages in it that, you in the old days, they drill a hole and stuff a steel ball bearing in there to block it off. And now we can build something just from the ground up that way. And we do use 3D printing technology, what we would call additive manufacturing, quite a bit. And the challenge, of course, when we think of traditional parts like a molded connector, is how many of these things do you need to make? Sure, prototypes, very functional prototypes, I will say, that look like the real thing. Tom, I could hand you one of our charging inlets today that was 3D printed, and you'd have a hard time knowing that it wasn't a production part. And we didn't spray paint it in the basement or anything like that, right? It came out looking really good. So, especially in this space where, for certain vehicles, we know that the volumes are not starting out at 350,000. They're starting out at 2,000, 5,000. They're trying the market with things. We will often use the additive manufacturing to put something together that can actually be used in the field. My opinion is we still have a ways to go to find materials that can really withstand the environmental challenges that we have. If you're going up to 125 degrees C for extended periods of time, rock chips, things like that, it can be a challenge. But we're not that far away from being able to do it. Frankly, I think mostly what keeps us from just saying let's just 3D print everything is just the speed at which you can stamp and you can mold product. It's just so cheap. Yes, building a tool costs some money, but as soon as you get, obviously we talked about economies of scale. As soon as you're making 100,000 of something, the cost of that tool pales in comparison to trying to keep a 3D printer running, unless you've got a huge bank of them. So I guess in summary, I'm very optimistic that technology is going to continue to develop at the same rapid pace that it has for the last 15 or so years. How far are we away from actually making regular production parts off of it? I don't know. Don't know. That's a big question.
All right. But my takeaway from that goes back to the partnership, right? Where a lot of people may be hesitant to approach a TE for fear of the tooling cost. Whereas if they want to try something out, they should know that, to try it out doesn't necessarily require that big investment. That only happens when the scale comes. So I hope that people can take away that, things that used to be daunting in their financial challenge now can be done more cost effectively in smaller volumes. And then, watch out for that design that can only be printed. And that's going to be a different game. And you're going to have some pretty unique features that can be created into a product that, previously we had no way to manufacture. So we're about out of time here. We covered a wide range of topics. I really enjoyed the dialogue. I want to thank you for participating in our podcast here today. Happy Friday, and we'll certainly be in touch in the future. And I enjoyed this immensely, and I hope you did too. And I hope everyone out in YouTube land enjoyed it as much as I did. So thank you.